Texan Global School. Circular sector. In this class, demonstrations and tools to calculate the area of a sector and the length of its arc are analyzed. Remember from previous classes that a radian is the measure of an angle whose vertex is at the center of a circle and which intercepts an arc on the circle equal in length to the radius. It is important to remember that pi radians equal 180 degrees. Precisely, an application of the radian as an angular unit is the calculation of arc lengths. Therefore, a circular sector is the portion of a circle delimited by two radii and a portion of the circumference called arc. If A, O, B is equal to 1 radian, then the arc A, B has length r. From there, the length of the arc L is equivalent to the product of the radius r with the theta angle, and the area of the sector denoted as A is equal to half the product of the square of the radius r with the theta angle. It is important to emphasize that the theta angle must be used in radians. The proof of the formula to calculate the length of the arc is performed by obtaining a proportion between the circumference and the arc of the sector. The circumference of the circle is one turn or rotation of 360 degrees, or 2 pi radians. This is proportional to the arc of the circular sector with its theta angle in radians, with equals value. The perimeter of the circle is pi times diameter, or 2 pi times r. Hence, we denote the length of the arc as L. Isolating, results the formula for the given arc length. The proof of the formula to calculate the area of the sector is similar. It is demonstrated by obtaining a proportion between the complete circle and a part or section of the circle called sector. The area of the circle is one turn or rotation of 360 degrees, or 2 pi radians. This is proportional to the area of the sector of the circle with its theta angle in radians, since the area of the circle is pi times the radius squared. Hence, let's denote the area of the circular sector as A. Isolating, results the formula for the area of the sector. Let's see the first example. We will find the area and the arc of a circular sector if its radius is 4 feet and its angle is 45 degrees. We will also sketch the sector. Remember that the angle of a sector must be in radians, so we will convert 45 degrees to radians first. As seen previously, pi radians equal 180 degrees. So, 45 degrees. How many radians is it equal to? By solving the rule of 3, results that 45 degrees is pi quarters of a radian. Now substitute into the formula to find the length of the arc. Since the radius is 4 feet and the theta angle is pi quarters, results an arc length of pi, approximately 3.14159 feet. Substituting to obtain the area of the sector, if the radius is 4 feet and the theta angle is pi quarters, results a sector area of 2 pi feet, or approximately 6.28318 square feet. With all the elements, we can sketch the sector, which opens with an angle of 45 degrees or pi quarters of a radian. In this other example, we will find the length of a circular sector if its area is 10 square meters and its radius is 5 meters. We will also sketch the sector. Using the formula for the area of the circular sector, substitute the given values and solve for the angle. We obtain that theta is equal to 0.8 radians. With the radius and the angle, we can obtain the arc of the sector. Substituting values results an arc of 2.4 meters. To sketch the sector, transform the angle of 0.8 radians to degrees. Results an approximate value of 45.84 degrees. We can draw the circular sector with all the values shown on the board. We will now solve the following real-life problem. The first thing we must do is the problem statement with a drawing. This helps to visualize the data and to be able to propose the tools for its solution. A pizza is divided into 10 equal parts. Each part has a radius of 5 inches. What is the area of each piece of pizza? We have only one data. However, the pizza measures 360 degrees, or 2 pi radians. If we divide the pizza into 10 parts, then we can divide 360 by 10. Therefore, the angle of each sector is 36 degrees. Transforming this angle theta to radians results pi fifths of a radian. Finally, We can calculate the area of each sector or each piece of pizza. Using the formula, substituting the data, results an area of 7.85 square inches. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com